All right, so we're looking at one more example converting different forms of complex numbers here. So we've got a complex number written like this: negative 4 root 2 plus 4 root 2i. And I'm going to write this in Euler's form. So I'm going to find the r value by doing the square root of a squared plus b squared. So the r value is going to be the square root of, I guess that's 16 times 2 plus 16 times 2. So I guess that makes 64 or 8. I guess that makes sense. Did I do that right? Yeah, because each of those is like the square root of 32. Cool. So that's the r value. And then the theta here, if I did arctan, what I would be doing is the arctan of 4 root 2 over negative 4 root 2, but that's in the wrong quadrant. And so I'm just going to add pi to that. And that's going to give me, instead of it being down in quadrant 4, where it's negative pi over 4, I'm going to add pi and I'll get positive 3 pi over 4, because that's in the correct quadrant. Anytime the real value is negative, you need to add pi to whatever your arctan tells you. So step 1 was rewriting our complex number as 8e to the I 3 pi over 4. So part B of the question says, what is something with the sixth root of z? Okay, the sixth root of z. Okay. So the sixth root of z then means that I'm going to take the sixth root of 8e to the I 3 pi over 4. So the sixth root of 8, I'll deal with that in a second. What can we even do with the sixth root of 8? Well, let me think on that for a second. The angle here is just going to be 1/6 as big. Just a second. All right, so I was at talking about the angle here. So the angle is raised to the 1/6 power. So I guess I can phrase that as 3 pi over 4 times a sixth. And that reduces a little bit, because 6 and 3, I guess we can pi over 8. So sixth root of 8 e to the I pi over 8. So I don't think that, pi over 8 is not on the unit circle. So I guess I could use a calculator here. I'm wondering if maybe I want to use the half angle identity, but I don't have the half angle identity memorized. So I think here using a calculator is a totally reasonable approach. So let's see what happens. So make sure you're in radian mode. And I'm going to do cosine of pi over 8. Let's see. Well, that's weird. Let me think here for a second. Sixth root of 8. Cosine of pi over 8 was 0.924. And then sine of pi over 8 was, oops, I didn't mean to write the word sine. Sine of pi over 8 is 0.383. Now the question asked me to show something involving roots. So what I'm going to do is I'm going to square those values. So I'm going to take cosine of pi over 8 and I'm going to square it. And let's see, that didn't work out. All right, so I think I might. Interesting. What happens if I square that value again? No. Square that again. No. Interesting. Let's approach this a little bit differently then. Okay. I'm going to try to prove a trig identity. Let's see if I can come up with the half angle identity. So the reason I'm talking about a half angle is because I know what the values are for pi over 4. So let's draw a little sidebar here. My calculator still didn't work out. So what I know is that if I have cosine theta plus I sine theta squared, I can write that in two different ways. I can write cosine squared theta plus 2 cosine theta sine theta 2I cosine theta sine theta, and then plus I squared sine squared theta. But I could also have written this as e to the 2I theta, because it's e to the I theta squared. And so here I have cosine squared theta minus sine squared theta, and here I have I times 2 cosine theta sine theta. And from the left side, I can say it's cosine 2 theta plus I sine 2 theta. And over here, I can get this all in terms of cosine by making this into 1 minus cosine squared theta. So we have 2 cosine squared theta minus 1. And then I have here, I'm going to deal with this later. So what this means is that cosine of 2 theta is 2 cosine squared theta minus 1, or if I solve like this, I get cosine squared theta, so I can square root it, and I'll get that. Great. So that's what I need. That's like my half angle theta of it. So what I know now is when I look at pi over 8 here, I can imagine that as my theta. So I know that the cosine value, I can say it's 6 root of 8 times the square root of cosine of 2 theta plus 1. So that's cosine of pi over 4. So square root of 2 over 2 plus 1 over 2. And I'm just going to call this I sine of pi over 8 because I'll get to that in a second. So now we have the 6th root of 8 times, we're going to make this into square root of 2 over 4 plus 2 over 4. So 1/2 is 2 over 4. Plus I sine of pi over 8. And that's pretty much what I wanted, except they've dealt with the 6th root of 8 here. Okay, so the 6th root of 8 Oh, that's how we can deal with the sixth root of 8. The sixth root of 8 is the same as the square root of the cube root of 8, which is just the square root of 2. So when we multiply the square root of 2 in here, what we have is the square root of 2 root 2 plus 2 times 2 is 4. And then the square root of 4 on the bottom is 2. So basically what I'm doing here is if you have the square root of x times the square root of y, that's the square root of x times y. Okay, great. And then I have over here the square root of 2 I sine of pi over 8. All right, almost done. Whew, almost had to give up on this video. We persevered, and we used a little bit of complex numbers to get the half-angle formula for cosine. And once you have the half-angle formula for cosine, you can get the half-angle formula for sine using cosine squared theta plus sine squared theta equals 1. So what I know is that this was my value for cosine. So I know that if I square that, square this value here, plus sine squared, I'll get 1. And so that means that sine squared theta, because squaring and square rooting cancels out, is going to be 1 minus root 2 plus 2 over 4. In other words, sine of theta is going to be the positive value. And I know it's positive because the angle pi over 8 is in the first quadrant. And so 4 over 4 means I have 2 minus root 2 over 4. And that means that the imaginary part of z, of the sixth root of z, is that value times the square root of 2. So we have square root of 4 minus 2 root 2 over 2. So that's a bit of a struggle, but again, persevered, used some trig to prove some things, and it was great. So let me know what I can do to help make that make more sense for you.